Hi dear students, welcome. So in this lecture we are going to discuss about the JEE Advanced paper 1 of the 2024, the yesterday's paper, today's paper. Alright, so here one by one we will solve the physics paper and paper question. Here I have the first paper, the first question. In the first question it is given that a dimensionless quantity is constructed in terms of the electronic charge E, permittivity of free space epsilon naught, Planck's constant, and speed of light. Then it is written in this equation. Then we need to find out what can be the possible value of alpha, beta, gamma and delta. Alright. Now look, electric charge, let's write down the dimension of electric charge. What is that? That is 80. Let us also write down the dimension of epsilon naught. So the dimension of the epsilon naught will be the dimension of Q1, Q2 divided by Fr square. Alright, so that will be A square T square divided by MLT minus 2 multiplied by L square. So in total that is M minus 1, L minus 3, A2, T4. Okay. The next one is the Planck constant. So of course we can easily calculate the dimension of Planck's constant. The energy divided by the frequency ML2T minus 2 divided by T minus 1, that becomes ML2T minus 1. Alright. Then the next quantity is the speed of light, and the speed dimension is LT minus 1. Now in the question it is given that the E power is alpha, epsilon naught power is beta, H power is gamma, and the C power is delta. Then we need to find out what are alpha, beta and gamma. So look, let us, because anyway we are going to equate this total dimension to a dimensionless quantities dimension, and that dimension will be M0, L0, T0 and A0. Alright. So look, let us find out all the dimension in the left hand side, e to the power alpha, epsilon naught to the power beta, h to the power gamma and c to the power delta. Let us find out the dimension in the left hand side for the m. So look, here m to the power is minus 1 and the power is beta, so that is minus beta. And here we have m to the power 1, that will be gamma. And the total, is there anything anywhere, any other m? No. So that should be equal to 0. It means beta is equal to gamma. We got one relation. Now next, if we calculate the total dimension of length, so there is no dimension in the electric charge, but here we have minus 3 beta, so we have minus 3 beta. Then here we have plus 2 gamma, and we have minus delta equals to 0. If I place beta equals to gamma, so here I will have minus beta, alright, minus beta, okay, this is positive, plus delta equals to 0, so I am getting beta equals to delta. Alright, so this is our second relation. Third relation we can get from the time. So the time power is alpha, then we have, okay, so let me write down alpha plus, here we have 4, so that is 4 beta, so that is 4 beta, and then we have gamma, and the gamma is minus gamma, so minus gamma, and the delta minus delta equals to 0. Let us substitute the values. So we have alpha, beta equals to gamma, right? So here we will be getting 4 beta minus beta, and delta is also equal to beta, so that's why minus beta plus alpha equals to 0. So we are getting alpha plus 2 beta equals to 0. Alright, so basically alpha equals to minus 2 beta. Now from here we can get the answer, no need to further solve it, because look, in the option they haven't given us anything. They are saying just suppose if this is n, these alpha, beta and gamma is some value, and there is a n, then what could be the possible values, right? So look, if I take by looking in the options, if I take the beta as minus n, so then gamma also becomes minus n, and then the delta also becomes minus n, and the alpha becomes 2n. So from this I am getting the first option correct. Alright, let us move to the next question. Here I am having my next question. So look, in the next question what they have given is that there is a infinitely long wire and it is placed along z axis. So something like this, the current is flowing outward in the plus z axis, and consider, suppose this is our x axis and this is our y axis. Now they have given the 2 points, these are 2 points, the minus root 3 a comma a, so somewhere here this is a point, minus root 3 a comma a, and there is another point a comma a, a comma a. Alright, now what they are asking, the magnitude of the line integral b vector dot dl along a straight line. So this is a straight line, then what is the line integral of the b vector dot dl? We just need to find out the value. Okay, so here first I need to calculate the b magnetic field value. I know the magnetic field due to the infinite wire. What is that? That is mu naught I divided by 2 pi r, simple from the Ohm's law, where r is the radial distance of the point for which we are doing the calculation, right? And the dl vector. So let us first just draw the magnetic field here, because the magnetic current is outside, that's why the magnetic field will be in the anti-clockwise direction, like this. Okay, now let us take a element over here. If I take a elemental length over here, the magnetic field is something like this. Let me redraw it. So here I am having this line and the magnetic field is like this. This is the wire. This is our radial direction. Let's suppose this is the perpendicular, and we know this distance is equal to the y coordinate, and that is a. Now this angle is theta. Okay, if this angle is theta, then this angle is also theta, then this angle is theta. This is magnetic field. Let's suppose the dl vector is in this direction, then this is dl. So if we want to calculate simply the b dl, so then b dl will be, b vector dot dl will be b dl cos theta. Alright, okay, now b is mu naught I divided by 2 pi r. Alright, b is mu naught I divided by 2 pi r, and the dl is dl, and that is cos theta. Now here the problem in this integration would be, I have 3 variables theta, l and r, so I need to substitute all of them in one of them. Alright, so what I am going to do is that I will replace all of them in the terms of theta. So for the theta, first I need to calculate the r. Look, this is the r, this is the r. Okay, this is angle theta. So, and this is a. Alright, so can I say that the can I say okay, yeah, r is a tan theta. Now let me rewrite it. Okay, yeah, this is our r, this is a. So can I say that the r, a divided by r is cos theta? So basically, yeah, a divided by r is cos theta, so r is a divided by cos theta. Okay, now dl, to find out the dl, what I am going to do is that I will consider this length as something l. Alright, so can I say that the l divided by a is tan theta? Alright, so then l will be a tan theta. If I differentiate it, then I will get dl. dl is a secant square theta d theta. So this is our dl. I got the dl. Did I got the Did I get the R? Yeah, that is A divided by cos theta. So let us place all of these values. So I have mu naught divided by mu naught multiplied by I divided by 2 pi, that is just a constant. Okay. Then I have dl. Dl is A secant square theta d theta multiplied by cos theta divided by R, and R is A divided by cos theta. Alright, yeah. So here I am getting A and A will be cancelled out, cos theta secant square theta will be cancelled out. So finally what I am getting is mu naught I divided by 2 pi and d theta. Now I need to look at the limit of this d theta. So look, we need to do the integration up to this point, and this is our starting point. So for this point I know that the angle is 45 degree or pi by 4. For this point I know that the angle will be because this is root 3, this is A, this is root 3A, so then this angle will be pi by 3. So I can say that the integration is minus 4 pi by 4 to pi by 3. Right? Usually you do this kind of integration in the electric field. So mu naught I divided by 2 pi, and theta integration is d theta integration is theta, and when we place the value pi by 3, and lower limit will become positive pi by 4. So that becomes 7 mu naught I divided by 24 pi. So yeah, again the first option is correct. Okay, let us move to the next. Alright, yeah. Here we have next question. Now in the next question what they have given is that there is a circular hoop that is placed on a xy plane. So I'm taking the xy plane like this. This is x-axis and this is the y-axis. Alright, and this is our hoop placed in this. And now in this hoop they have given that there are two charges. So there is a charge placed down somewhere here which is having a glue on that, so that is fixed, it cannot move. And now there is another charge same as this charge, so of course, and that is free to move on this frictionless hoop. So I know from the repulsion it will be at the maximum distance, so it will be at the opposite point, isn't it? Yeah, so it is at the opposite point. Okay, so this is Q, this is also Q. Now what they are saying that if we give a small displacement through this, what will be the frequency of the oscillation, what will be the omega, that we need to find out. So look, let us draw this hoop again in the top view. So this is our hoop, and this is our positive charge, and this is our positive charge which can move, the other bead which can move. Okay, initially it will be like this. Now let us give a small displacement of the theta, a very small displacement of the theta. Theta is very small, so then bead will be moving over here. Okay, and now if I release it, so due to repulsion the force is in this direction. Okay, this is force, let's say whatever that force is there, F at this point is in this direction. Now if we look from the radial direction, this is our center, this will be our radial direction. Alright, now if this angle is theta, then this angle is also theta, that's why this angle is theta. Alright, so because of that, because of this theta, this force will have two components. If I draw it this bead again, so there will be a component in this direction, and that component of course would be F cos theta. Another component is in the tangential direction, and that is F sin theta. And remember that theta is very small, can I write it as F theta? Okay, now this force cannot move, it will just increase the normal, it will just change the normal. Okay, so it won't move, it is the cause of the movement, and there is no friction, so that's why the net force in the tangential direction is this force. Alright, now I will assume that this distance is 2r. If I change the small angle, then as well this distance will remain 2r only. Okay, So what is the F? F is kq square divided by 4r square. This is the force. Okay, so basically what is the force in the tangential direction? That is F multiplied by theta, that is kq square divided by 4r square multiplied by theta. Okay, yeah, we got it. Now what to do? We got the restoring force, but it is in the terms of theta. So what this bead will do, it will do the angular SHM like this, about this point. Now look, if this is theta, then this is theta, then this angle will be 180 minus theta, isn't it? If this angle is 180 minus theta, tell me this angle, how much is this angle? Will it be 180 minus, will it be 2 theta, this angle? Yeah, so this is 2 theta. Alright, so we have yeah, this angle is 2 theta. Okay, then next what we can do is we can calculate the torque due to this force about this point, and let's do the tau equals to I alpha. So the torque will be the force multiplied by the perpendicular radius r. So the torque will be simply kq square divided by 4r square multiplied by theta multiplied by r. That becomes kq square divided by 4r multiplied by theta. Okay, now yeah, this is our torque. Torque is I alpha. I is mr square, because we are calculating the moment of inertia of this bead about this point. Mass is m, so that's why the moment of inertia is mr square. So mr square multiplied by alpha is the torque kq square divided by 4r multiplied by theta. Okay, now look, this theta here, it is this theta is 2 theta. So if I replace this theta, I can replace this theta in the terms of this this theta dash as theta by 2. So then it will be kq square divided by 4r multiplied by theta by 2. Okay, and here I have mr square multiplied by alpha. So alpha becomes kq square divided by 4r multiplied by mr square multiplied by theta by 2, so theta by 2. Okay, yeah, so alpha becomes kq square divided by 8mr cube multiplied by theta. So yeah, now k can be written down as 4 pi epsilon naught. So alpha is basically 1 divided by 4 pi epsilon naught, 4 multiplied by 8, so that is 32 pi epsilon naught mr cube, and here we have q square multiplied by theta. So this is omega square, this is the value of omega square. So let us check which option is correct. So this option is correct according to me. Now let us move to the next question. Here I am having the next fourth question. Look in the fourth question, what they have given, that there is a block of mass 5 kg and the force is minus 20x plus 10 Newton. Okay, and at t equals to 0, this particle is in rest, so the velocity is 0 and it is at x equals to 1 meter. We need to find out the position and the momentum of the block at t equals to pi by 4. So finally I need to calculate the position in the terms of time, so that I can find out the position, and the velocity in the terms of time, so that I can find out the velocity and I can find out the momentum. Now we know there is a very well known approach for this kind of question, is that we find out the acceleration, that is force divided by mass, and that is minus 20x plus 10 divided by 5. So the acceleration becomes minus 4x plus 2. Now acceleration is v dv by dx. If we substitute that formula, then we can integrate this. So v dv is minus 4x plus 2 multiplied by dx. So v square divided by 2 is minus 2x square plus 2 plus some constant c, 2x plus c. Yeah, so this is the integration. Now let us first find out the c. So they have given that the velocity was 0 when the particle was at x equals to 1 and the time was 0. So we can substitute these two values and find out the c. So v is 0, 0. That is also 0, minus 2, and this is plus 2 plus c. So we will get the constant at 0. So we got this constant at 0. Now what? We got a equation of v square. So v square is minus 4x square plus 4x. Right? This is v square. And from here we can also find out the v. V is basically minus, we can take 4x common, then we have 1 minus x root. This is the velocity. This is the velocity. Okay. Now I need to find out the velocity in the terms of time. So I will integrate. I need to find out the displacement in the terms of time, or the position in the terms of time. So dx by dt is this value, 4x multiplied by 1 minus x. Now let me rearrange it. So I have dx divided by 2 times of root x 1 minus x is equals to dt. Now here it seems a bit complicated integration. So what I will do is that I will assume that x is sine square theta. Alright. So then I will get the dx as 2 sine theta cos theta d theta. So let us place the value of dx. Dx is 2 sine theta cos theta d theta divided by 2 and root over sine square x and 1 minus sine square x is, of course, that is cos square x, is equals to dt. Alright. So what do you think? Will it be cancelled out? Yes. So this is integration of d theta is equals to integration of dt. So that is basically theta is equals to t plus c. Theta is t plus c. We are getting this. Theta is t plus c. Now what is theta? Look over here. We have sine square theta. So theta is basically sine inverse of root x. Let us place this value. So theta is sine inverse of root x is equals to t plus c. Now what they gave us was this, that at t equals to 0, the particle is at t equals to 0, the particle is at x equals to 1. Alright. So let us find out what will be the constant value. So sine inverse root 1 is equals to c. So c value is pi by 2. Alright. Yeah. So then we are getting the sine inverse of root x is equals to t plus pi by 2. So basically we are getting the root x as sine t plus pi by 2, and we know sine pi by 2 plus theta is sine theta, right? Cos theta, sorry. So that becomes cos t. So x becomes cos square t, right? So this is the position. Let's find out the position at t equals to what is the question, what they have given. We need to find out the position at pi by 4, t equals to pi by 4. Alright. Yeah. So if I place t equals to pi by 4, then t equals to pi by 4, and then x will be 1 by 2. So that is basically 0.5 meter positive. If I differentiate it, I will get the velocity. Dx by dt is the velocity, that is 2 cos t multiplied by minus sin t. that becomes minus 1, isn't it? Now we need to find out the momentum. Momentum would be mass multiplied by velocity, that is 5 multiplied by minus 1. So minus 5 meter kg meter per second. So this is our momentum. Okay. Now, yeah. So we have got this answer correct. So this is a bit long method. There could have been a short method for this. Look, this is actually a damped force. This is a damped oscillation where we have some extra force 10 Newton always acting, right? So what will happen in this is that we can find out the frequency of this from using this expression. So we have minus 20x, that is the restoring force always acting. If we divide by the mass, we will get the acceleration, that the basic term of the oscillation, minus omega square x. So that basic term will be the minus 4x, right? So we will get the omega as omega will be omega will be 2. So then the time period will be 2 pi by omega. So then that will be 2 pi divided by 2. So that is pi, right? Now look, what is happening with this is somewhere the particle is there at t equals to 0, x equals to 1. Let us also find out the mean position of this particle. So look from here, minus 20x plus 10. So the force will be 0 at x equals to 0.5 meter, right? So x equals to 0.5 meter, the force will be 0. Now look, the time is 5 seconds. So now because of the any damped oscillation, the time period won't change. So the complete oscillation's time period will always be pi only. So from the extreme position to mean position, the time to go will be pi by 4, right? So you could have told it directly that the x is positive 0.5, okay? And you know, when this is positive 0.5, there is only one option. Of course, we know at the mean position velocity won't be 0, so that this is incorrect. So this is how we could have done using the concept of this damped oscillation. Now let us move to the next question. This is our 5th question. Yeah. Look, this is an interesting question. Of course, all the questions are interesting. Yeah. So look, here we have a force, that is, because of that there is a particle which is doing the circular orbits motion. So this is the force, and the potential they have given. I think there won't be any use of this, and they have given that this follows the Bose quantization. So angular momentum is n multiplied by reduced Planck constant h. Okay, so by simple using the Newton's laws, we can say that the force acting toward the radial inward direction should be equal to the centrifugal force. Alright, so we will get a relation from here. What will be that relation? That relation is kr square equals to mv square. Quite simple. Now next, using this I will get a relation. What is the angular momentum of a particle above the center? mvr, right? That is n reduced Planck constant h. Okay, I need to find out the r. So what I will do is I will find out the velocity value. So velocity, can I write down it as n reduced Planck constant divided by mr? Is there any problem? Let us substitute that into this equation. So then we have kr square equals to m, and the v square will be n square h square divided by m square r square. Is that okay? Now look, here m and m will be cancelled out. We have, let's write down the r one side. So then we have r to the power 4 is equal to n square reduced Planck constant square divided by n k. Okay. Yeah. Now let's take a square root. So then we will get r. R is n h square root. So here I will get r square, not the r, and that will be n h divided by root of mk. So the first option is correct. Now v square. Look over here. I have the v. If I do the square of that, then I will get v square, that is n square h square divided by m square, and 1 by r square. Look from here, it will be n by h, n multiplied by h, and this will go in the numerator, so the root mk. Alright, square will be basically NH root mk divided by m square. Now NH, if I take this m square in the root, it will be m to the power 4 and m will be cancelled out, then it will be k divided by m cube. So this option is also correct. Next, L divided by mr square, that we need to find out. So look over here, I have L. L is NH simply, and the R square is this value, we have got it. So MVR, that is basically L divided by R square is NH divided by R square value is NH divided by multiplied by root of 1 by mk. Alright, so NH will be cancelled out, then it will be simply root of mk. Alright, yeah, root of mk. And there is, this is not L divided by R square. Actually, in the option they have given L divided by mr square. So let's multiply by m as well. So we have in the denominator m. So then we have root k by m. This is our L divided by mr square. So it means this option is also correct. Now look in the next option, the energy. What is the energy? Energy is half mv square. Now half m v square I just calculated, that is v square. So we have nh multiplied by root k by m cube. Okay, let us simplify it. So E is n reduced Planck constant, and if m goes inside then it is m square, then this will be root k by m, I think. Yeah. Okay, and yeah, of course there is 2, I have just forgotten it, there is 2. So this is this option is correct. So all the options are correct in this. Now next, yeah, so this is another question related to the this waves on string. Now look, we know that whenever there is a joint point, that joint point will always form a node. So that's why this third this option, no vibration mode with an antinode is O is possible for the composite ring, so that is correct. And with an antinode O, the minimum frequency of vibration of the composite ring is 2, we know that is not possible. So D is correct, B is incorrect. Now look, when this, let us find out what will be the velocity in this. So velocity will be root T by mu, T by mu. The velocity for this one will be V, let's suppose this is V1, then this is V2, that will be root T by 4 mu. Okay, so that is basically V2 is V1 by 2. Alright, now they are saying that this is V node. Let us see what happens in the V node, at the V node in the first string. So in the first string, at the V node, we know that the frequency is V divided by lambda. Okay, let's suppose this is the fundamental frequency of this string, where this is the node and this is node. So then this is lambda by 2. So basically we are getting lambda by 2 as L, so the lambda is 2L. So we are getting V is the velocity, so root T by mu divided by 2L. So 1 by 2L root T by mu. That means they have given this as V naught. So they have given the fundamental frequency of this light string as the V naught. Now let's see what happens, what is the fundamental frequency of this this heavier string. So this is our heavier string. So fundamental frequency will be V by lambda. So the lambda will be the, when we take fundamental, this will be the node and this will be the node, total length will be 2L. So then the lambda will be 4L. So we get from here that V is, of course, that is V naught divided by 2. Okay, or let me rewrite it. Now instead of writing V, I'm writing it as in the terms of T and mu. So that is basically root T by 2 mu divided by total length is 4L of the lambda. So F is basically 1 by, okay, this was 4. So this is 8L root T by mu. Okay, this is our fundamental frequency of this one. Now to vibrate, I need to increase its frequency. I need to increase the number of nodes so that I can match the frequency, because any string, if they are combined, they will have the same frequency, right? So if I keep on increasing, so then there will be one more node over here, there will be one more node. This is how I will keep on increasing the frequency. So look, if I take the one node in between, then the string will be like this. Then the frequency of this first, let's call it first overtone, so then F1 is 1 by 2 root T by mu. This is the velocity for this one, because the mass density is 4 times, and the total length, now look over here, this is the total length. This total length 2L becomes the lambda, so 2L. So frequency is 1 by 4L root T by mu. Still it is not matching. What if I do the half of this? Okay, so like let us do like this. So in this case I will have the 2 lambda as 2L. So 2 lambda is 2L. Then lambda is simply L. So then I will get the frequency as 1 by 2 root T by mu divided by L. And this frequency is matching with the frequency of the lighter string. It means at this frequency both of these strings will do the resonance. They will vibrate. They will have fixed node and fixed antinode. Now in this case, let me count how many nodes are there. So 1, 2, 3, 4, 5. Now after this there is a string. So this is our string, which is lighter string, which is performing in the fundamental. So that will be like this. So in this case, when they will vibrate in the fundamental mode, this many node will be there. 1, 2, 3, 4, 5, 6. So 6 node will be there. Alright, yeah. So now let's read. So the first option says, with a node at O, the minimum frequency of vibration for the composite string is V0. Yeah, absolutely correct. When the composite string vibrates at the minimum frequency at node at O, the 6 node including the AND node, there are 6 node including AND node, this is also correct. So according to me, A, C and D are correct for this. Okay, now we have the next one. Here I have this combination of the mirrors. In the combination of the mirror, we know that the equivalent power is P1 plus P2, so on we will add. Now what is happening in this case is that they have polished this surface. Okay, so in this case, let's suppose the power of the first one is P1, second one is P2, and this mirror power is P3. So what will happen? That first there will be a reflection, so P1, then the second reflection P2, then the reflection P3, and then now because rays are going back, that's why again P2 and then again P1. This will be P equivalent. Now look, this surface is a planar surface, so F will be infinite, so that's why 1 by F will be 0, right? So the P3 will become 0. Now let's suppose the refractive index for this one is N. So we have this first lens like this. It will be a kind of lens, right? Let's find out the P for that. So we know 1 by F is mu minus 1 or N minus 1. Let's write down N minus 1. 1 by R1 minus 1 by R2. Okay. So 1 by F is this N minus 1. So the rays are coming from the air to this N minus 1. And 1 by R1, so 1 by R1 is 1 by infinite, so that is 1 by infinite, minus 1 by R2, R2 is positive, so 1 by R, okay, that is our 1 by F, so 1 by F is minus of N minus 1 divided by R. This is the power of this lens P1. Okay, what about the next lens? Look, the next lens is the plano-convex. So P2 will be the refractive index of this, so that is mu minus 1. We are separately calculating for it, and 1 by R1 minus 1 by R2. Now the rays are falling like this, so first they will face this, so that's why 1 by R1 will be 1 by R, and the 1 by R2 will be 1 by infinite, so that is 0. So this is our P2. Alright, now if I calculate the P equivalent is sum of all the P's, P1 plus P2 plus P3 plus P4 plus P5. We know that P3 is 0, and the P1 and P5 are equal, P2 and P4 are equal, so that becomes 2 times of P1 plus P2, that becomes 2 times of P1. P1 is uh, minus of n minus 1 divided by R, and the P2 is mu minus 1 divided by R, so that becomes 2 divided by R, and here I am having mu minus n. Okay, mu value they have given in the question. What is the value? They have given that the refractive index of this material is 1.6. Alright, so I have this as 1.6, so 2 divided by R. Of course they have also given the R, the radius of curvature of this surface, and that is radius of curvature of convex surface is 9 centimeter. So this is 9 centimeter and this is 1.6. So 1.6 minus n divided by 9 is equals to R, right, of this complete. And can I say that is basically 1 by F? Okay. Now what is F? F is for R by, F is R by 2, right? If we consider this as complete, like this is working as a complete mirror, because they are asking that the rays should retrace, so this should work as a mirror, then the rays should follow the same path, right? Then can we say that this object should be at the radius of curvature, right? So just we need to find out the radius of curvature of the combination, that's all. So F is, we know, R by 2, so that is 2 by R is equals to 9 to 1.6 minus n. Okay, 2 will be cancelled out, so basically R is 9 divided by 1.6 minus n. This is the radius of curvature, and at that place only we should place the object. So the n, R is 9 divided by 1.6, and now the first value given in the option is 1.42. Let's have a look what will be the R value, or the height of the object where we should place the object from the water surface or the below surface. 9 divided by 1.6 minus 1.42, that comes out to be 50. So look, in the first option they are saying if the n is 1.42, then h should be 50, so that's correct. Now let's move to the next one. N is 1.35, so then what should be the R? Let's find out. So 9 divided by 1.6, and we have 1.35. So this is 36 centimeter. 1.35. This is 36 centimeter. Alright. So that option is also correct. This option is also correct. Alright. Now let's move to the next question. Here I am having my next question. Question number 8. Now what they are saying in this question is that the specific heat capacity of the substance is temperature dependent and is given by a formula C equals to KT. K is constant suitable dimension of SI unit, and T is the absolute temperature if heat required to raise the temperature of 1 kg of substance from minus 73 degrees Celsius to the 27 degrees Celsius is Nk. Then what is the N value? Okay, so let us first change this the temperature. So the T1, the initial temperature is minus 73 degrees Celsius plus 273, that will be in the Kelvin, and what is that? 200 Kelvin. And the final temperature is 27 plus 270, so that is 300 Kelvin. Now we need to change the temperature. We know that the heat absorbed by the material for the dt temperature change is dq equals to ms delta t. Now s can be a constant or a variable. Right now they have given the specific heat capacity as a variable, right? So then dq is m kt dt. Alright, here we have mk as constant. Let's take out, and integration of this one will be t square divided by 2, and we have the limits from 200 to 300. This is our total q. Q is mk and the limit is 300, so that is 9 multiplied by 10 to the power 4 minus 4 multiplied by 10 to the power 4 divided by 2. M is 1, mass is just 1 kg, so k times of this value, and that is 9 minus 4, 5, 5 divided by 2, 2.5, 2.5 multiplied by 10 to the power 4 is 25000. Is that correct? Yeah. So this is the value. Yeah. So this question is integer, of course. So then you need to place this value 25,000. That is the answer. Let us move to the next question. In this question, I thought that the diagram is a bit incorrect. Maybe I may be the wrong diagram. I was not able to understand from the statement and from the diagram what is the question. So I thought of this a bit differently. So a disk of mass m, radius r is free to move in about vertical axis a, and battery is operated. It is operated by a battery, negligible mass fixed to disk at a point of its circumference. So what I was thinking is, this is the top view of the disk. So this is the disk, alright, and there is a motor over here. A motor will certainly have a shaft. Okay, so this is the shaft of the motor. Now another disk of m and r radius is fixed to the motor's thin shaft. So what I was thinking, that this should not be the diagram. The diagram should be something like this. Okay. Okay. Yeah, I was thinking like this. Now the radius of this one is r. Radius of this one is r by 2. Okay. Then what? So if the angular speed of this one is omega, then this one is omega by n. Then what is the n? So look, there will be some omega of this motor, because of that both will rotate. Alright. So if that is omega, let's suppose the radius of the motor shaft is small r. Can I say omega r is the velocity of all the points in the contact or in the circumference? And now because they are rotating, there should not be any slipping. So that's why the velocity of this disk should also be at this point. The linear velocity should also be equal to this value, omega r, right? So that is omega, let's call it as omega dash, omega multiplied by r by 2. Okay, and this should also be equal to this velocity at this point, which is omega by n multiplied by r. So if I equate these two values, so then I am getting r will be cancelled out, and omega cancelled out, so n is 2. So n is equal to 2. Now I thought it like this, so my solution may be incorrect. Somewhere I have misunderstood this question. Next. Look, a point source is emitting a intensity uniformly in all the directions. So now there is a point A somewhere here, and this is our source, and there is a point B somewhere here. Now we know that if it is uniformly distributing the energy in all the directions, then the intensity at all the points will be same if they are at the equal distance. Okay. So R is initially IA divided by IB, which is 2. Okay. Now what is happening is that it means, can I say that the IA is 2 of IB? This is initially. Alright. Now if a set of the two polaroids having 45-degree angle between their path axis is placed just before the point B, the new value of R will be. Look, I am placing the two polaroids. over here. If I place the two polarides, so then what will happen? The first polaride will give the 50% of the intensity. So initially the intensity was IB. Now the after first polaride it will be IB dash, which is IB by 2. Okay. Then I have placed the next polaride in front of it, where the intensity will be IB double dash, and the angle of this polaride with the first polaride is 45 degree. So we know IB dash will be IB double dash will be IB dash. Okay, here IB dash cos square theta, where theta is the angle between the polarides axis. Now that is, look, we have IB dash is IB by 2, so IB divided by 2, and cos square theta is 45 degrees, so that is 1 by 2. So we are getting the IB double dash as IB by 4. Okay. Now again we need to find out the ratio. A is not changing, so IA is IA only, but B is IB double dash. Okay. So IA divided by what is IB double dash? IB divided by 4. So that is 4 times of IA divided by IB, and IA by IB initially was 2, that becomes 8. So 8 is the answer for this question. Alright. Now next. Here is our next question. Look, in the next question, in this question they have given us that the source and the object both are moving, observer both are moving, right? Okay, and yeah, here we need to find out the frequency in the second case. Alright, so what I was thinking, that we can apply the Doppler's effect and then we can do the calculation. Look, what is the apparent frequency? Apparent frequency is V plus minus V observer divided by V plus minus V source multiplied by the real frequency. And we know that the condition in this is when the source, let's suppose this is our source, this is our observer, which is also given in the question. If the source moves away from the observer, then it is considered positive, and then if it is moving toward the observer, then it is considered negative. And observer, if it is moving toward the source, then it is positive, either it is negative. Now in the first case, the first sign will be this sign will be negative sign, and this sign will be a positive sign. So the F dash will be basically from here, the F dash is 240 multiplied by 343, which is the velocity in the air, divided plus V divided by 343 minus V multiplied by the 240, the original frequency. And this frequency is given as, this value is given to you as 288, right? 288. From here, if we do the V calculation, we will get the V, and this is the value of V. I have done the calculation, okay? So you can do the calculation later on. Yeah, so this is the velocity. Okay, now what is happening in the second case? They are reversing the velocity, so signs will be reversed. So apparent frequency will be V minus V naught divided by V plus Vs multiplied by F. Alright, so this is 343 minus 343 divided by 11 divided by 343 plus 343 divided by 11 multiplied by the original value 240. Okay, if we do the calculation, then we will get the apparent frequency as 200 Hertz. So the apparent frequency in this case is 200. That is the answer. Now we have our next 12th question. Now in the 12th question, what they have given, that there are two identical tanks which are placed on the H-height building. Both are very identical to each other, and we have filled the water in both of them up to a height of h, small h. They are at a height of building of 16 by 9 multiplied by h. Now here I am having the hole in both of them at the bottom. Now what we are doing is that from the both water will flow. For the first one there is nothing connected, so the water will directly flow like this. For the second one we have connected a pipe, and this pipe goes up to ground like this, up to the height h ground. So because of that there will be some change in the velocity, right? Now the velocity won't be root 2 gh in the second case, it will be something different. Okay, yeah. So the time for the first one and the time for the second one, we need to find out the ratio. For the time for the first one there is a direct formula. You can do the, of course you can do the integration, and from there as well you can find out. Let me tell you the integration so that you can do if you have doubt. So we know that the velocity at this point is simply root 2 gh multiplied by cross section area. Let's suppose the cross section area of this one is a1, that will be equal to, this is the rate of flow, which is water is flowing out. That rate of flow should be equal to this rate of flow at this point, that is cross section area multiplied by the velocity of the movement of this surface. That let's write down, that is in the terms of the h, then that is dh by dt. Now from here if we do the integration of the h from h to 0, then we will get the time, and the time will be root 2h by g multiplied by a2 divided by a1. This is the time. Okay, for the second one, now look, in the second one the velocity won't be root 2 gh, but the velocity will be root 2g small h plus capital H, right? Because we are exiting the water at this point, so it is kind of free fall. So free fall height is h plus h, that's why the velocity is root 2 gh plus h. From here the velocity will be 2g, and h plus h is h plus 16 by 9, h is 25 h divided by 9, so that becomes 5 by 3 root 2 gh. Alright, we got the velocity. Now we have the velocity, we need to find out the time. So again what we will do, v multiplied by a1 cross section area is same, that is a2 multiplied by dh by dt. Okay, so here we have dt integration is a2 by a1, this is just a constant, and then 5 by 3, then root 2g, that is also a constant, and root h dh integration. Alright, so we have this. So root dt integration is simply t is a2 divided by a1 multiplied by 5 by 3 root 2g, and root h integration will be, okay, this root h will be in the denominator, so that's why that is 1 by root h. Okay, when we do the integration we will get h to the power 1 by 2 divided by okay, this root 2g is also in the denominator. Let me write down, this was complete in the denominator, root 2g and the h. So h integration, root h integration is h to the power 1 by 2 divided by 1 by 2 multiplied by 2, and the limit is, now the difference is in the limit. The limit is the lower limit will be this value and the upper limit will be this value. Okay, of course due to the negative sign that will change, so I am directly putting it from h, which is 16 by 9 h to 25 by 9 h. So this is 16 by 9 h to 25 by 9 h. So t is a2 divided by a1 5 by 3 1 by, okay, of course that is root 2 by g, root 2 by g, and here there is root h as well, so root h, and it will be, will it be 5 by 3 minus 4 by 3, alright, yeah. So the t is a2 by a1 and root 2h by g, which is similar of the previous calculation, and multiplied by 5 by 3 multiplied by 1 by 3. So that is 5 by 9. So what we need to find out is t1 divided by t2. Okay, t1 divided by t2 is a1 a1 a2 divided by a1 root 2h by g. This was our t1, divided by t2 is a2 divided by a1 root 2h by g, and this is 9 by 5. Okay, so we need to give the answer in the where is that question? Yeah, we were getting this 5 by 3. dt is this value. Just wait a second. 5 by 3. Okay, actually it will be 3 by 5. I have done a bit calculation mistakes over here. So this is 3 by 5. Yeah. So actually all the places it is 3 by 5. Let's keep 3 by 5. So 3 by 5. And now look, it is 3 by 5. So then it would be, yeah, here it would be 3 by 5. So 3 will be cancelled out. So basically it is 1 divided by 1 by 5. So that is 5. So the final answer will be 5. Thus I have done this mistake that I did initially as well, but I corrected only for this part. I did not correct it for this. So that was the reason. The answer is 5. The next one, yeah, this one. Okay, look in the question. So there is a rod which is connected to this string, and the mass of the rod is m, and we are giving a impulse p here. This is a linear impulse at a distance x from the center of mass of this rod, in such a way that they should move together. They should move like this. Okay. Then what is the x value that we need to find out? So in this case, what I was thinking is that this will be the instantaneous axis of rotation for this one. The O point will be the instantaneous axis of rotation for this complete system. So I will find out the omega about this point O, and I will find out the omega by using the torque about the center of mass, and both omegas I will equate. So look, in the first case, we know that the linear impulse is angular impulse is linear impulse multiplied by the total length from the axis of rotation. So the axis of rotation for the point we are considering this point. So that is 3L divided by 2. Total length is L plus L by 2, 3L by 2 plus X. Okay, this is the angular impulse. That should be equal to I omega. I is the moment of inertia of this rod about this axis, and that will be ml square divided by 12. Let us find out the I. That is ml square divided by 12. That is about the center of mass, plus md square, and md square is this distance. So d distance is this distance, and that is L plus L by 2, which is L plus L by 2 is 3L by 2. So that is m 9L square divided by 4. So if I do the calculation, I will be ml square and 28 divided by 12, right? Okay, yeah. So I is basically 7 ml square divided by 3. About this point, this is the I. So then can I say that the P 3L divided by 2 multiplied by X is equals to 7 ml square divided by 3 multiplied by omega. This is when we are doing the calculation about the center point O point. Now let's do the calculation about the center of mass. About the center of mass, the impulse would be P multiplied by X. That should be equal to the I omega, and omega will remain same because omega for any, if the body is doing the pure rotation about a point, so then omega about that point and omega at about all other point will be same only. That won't change. So that's why about the center of mass, the moment of inertia is ml square divided by 12 multiplied by omega. Alright, so that divide both of them. So then P will be cancelled out. ml square will be cancelled out. 3, 4. Right. So when we do the calculation, something we are getting here. We are getting the, okay, yeah, omega will be cancelled out. So 7x is equals to, now this 4 will be in the numerator, will be going in the numerator. Alright, So 7 multiplied by 3, 7 multiplied by 4 is equals to 3L divided by 2. Okay, yeah. Is that plus x? I think this calculation is correct. So here I am having the 28. So 28 x minus x is 3L by 2. So then 27x is 3L by 2. So that is 9. So x is L by 18. So this is the distance. Now what they are asking in the question, they are asking if the distance is L by n, then what is n? N is 18. Next question. Now here this is a PET cycle. Now I won't use the PT cycle. I will first write down the PT. From this PT cycle I will write down the PV cycle. So look, for the PV cycle I have this point. Let's consider the volume as V naught. So then there is a point something P naught V naught, P naught V naught. Alright. From this point to another point I am moving, that this is our J point. So from J point to I am moving K point. I am just increasing the temperature, pressure is constant. So then only the volume will increase and this volume will become 3V naught. So this is a isobaric process. And then from that point the temperature is not increasing, so that is isothermal process, and the pressure becomes 2 times, so volume will also become 2 times. So this is 3V naught, then this will become 6V naught. Okay. So yeah, sorry, here I have done a bit mistake, right? Yeah. So what is happening is that we are increasing the pressure and the temperature is constant. So then PV will be constant, right? So then the value will be something like this. Okay. Here volume will become half of that. So that will be 1.5. This will be 1.5 V naught. And the pressure will become 2 times 2P naught. After that what is happening is that the pressure is not changing, but the volume is becoming, temperature is becoming 1 by 3 times from this L point. So JKL, from the L point the temperature is becoming 1 by 3 times, and the volume will also become 1 by 3 times. So that is 0.5V. And from this point to again this point, J point. So this is our cyclic process. Now what I am doing is I am starting with this S. So changing the internal energy of the gas in the process M to J. So this is our M to J process, JKL M. So M to J, if we look in this M to J, we know that the temperature is constant. If temperature is constant, then there won't be any change in the internal energy. It means S should be 2. So by this I can eliminate the 2 options, the first and the fourth option. Now look, in the next I can solve the heat given in the process K to L. Okay, process K to L. What is the heat given? Temperature is constant. We know if temperature is constant, then dQ will be equals to dW, right? And dW will be nRT, whatever the temperature is there, ln V2 divided by V1 or P1 divided by P2. So we are going from K to L, K to L. So that is P1 divided by P2, so 1 by 2. Alright, this is 1 by 2. And yeah, and the temperature is 3T naught. Can I say that is minus 3RT naught ln 2, isn't it? Yeah. So H should be 5. So R should be 5. Yeah. So B option is correct in this. Now let us move to the next one. Okay, so here I have been given the multiple thin plates, and using them I am forming a conductor. There are different situations, and in them I need to find out the equivalent capacitance. So look, these are our plates. Let me write them like roughly like this. These plates will have two sides. Okay. Now, in the first case, we need to find out between the S1 and S4. It means the battery is connected in between that, and the with 2 and 3 not connected. So this is simply like this. Okay. So in this case, look, these two will form a capacitor. So there will be a capacitor like this, then the another capacitor like this, and then the another capacitor like this. So what is the equivalent capacitance? C naught divided by 3, right? And where C naught is the capacitance of one capacitor. All right. Yeah. So basically P is 3. From this I can only eliminate the one option. Now next, let's move to the Q. So what they are saying, that capacitance between S1 and 4, where 2 and 3 are sorted. So like this, I have 2 and 3 are sorted. Like this. Now look, there won't be any charge stored over here, so there will be just two capacitors like this. So then this is C naught divided by 2, series combination of two capacitors. So then in the Q, the option second is correct. So Q, the option second is correct. So again, I am not able to eliminate anything. So let's move to the R. In the R, we have we need to calculate the capacitance between 1 and 2 with the 2 and 4 sorted. Okay, 1 and 2, 2 and 4 sorted. Okay, so something like this is our capacitor, and 1 and 3, and with 2 and 4 sorted. So we need to find out between them, and 2 and 4 are sorted. We need to find out between them. So look, this is 1, 2, 3, 4. So 1 and 2, okay, this is 2. Then 2 and 3 are forming a capacitor. So 2 and 3 are forming a capacitor. This is our 3. Alright, and then this is third plate, and this is the fourth plate. Fourth plate is connected to 2. Okay, like this. This is our combination. So then this is C naught divided by, this is 2 C naught and this is C naught. So that is 1 by 2 C naught plus 1 by C naught. That becomes 2 C naught divided by 3. Yeah, so that is 2 C naught by 3. So which option is correct? 2 C naught divided by 3 R. So fourth option. So it means D is incorrect, R is fourth. Okay, I need to calculate all of them. The capacitance between S1 and S2 with 3 sorted to S1 and 2 sorted to S4. Okay, yeah, S1 and S2. So S1 and S2. These are our terminals, and 3 and 1 sorted. So 3 and 1 are sorted. Okay, and then the 2 and 4 are sorted. 2 and 4 are sorted. So look, we have first plate, first capacitor, second plate, second capacitor, that is also connected to terminal. Second plate, second capacitor, third plate, first capacitor, third plate capacitor is also connected to the terminal. The third plate, second plate, and fourth capacitor, first plate, that is connected. So what is that? 3 C naught. So this is 3 C naught. Yeah, 1. So the C option is correct. Alright, so we have done the paper discussion of today's JEE Advanced. Of course, there is second paper as well remaining, so I will do the next day. We will solve that. Let us just revise the answers so you can mark your answers. Yeah. I hope you will remain connected to our YouTube channel for the further studies if you want to do related to the physics and the science. Yeah. So the first question, A option. Then second question, A option. Third question, B option. Fourth question, C option. Fifth question, A, B, C, D, all of them correct. Sixth question ACD correct, and seventh question A and B correct. Eighth question, yeah, answer was 25,000. Ninth question answer was 2, and the 10th question answer was 8, and the 11th question answer was 200. 12th question answer was 5. 13th question answer was 18, and 14th question answer was B, and 15th question answer was C. Let us end over here. Thank you very much for joining. We will discuss the next paper in the next